Okay, so we are doing 4.4 today. We're in your student companion. We're on page 87. And lucky you, we are skipping the launch. So what I want you to do right now is pause me here and write all this down. Yay! So pause here, write all this down. When you're done, play again. Okay, so this is your key concept. Today we're learning about adding, subtracting, multiplying, and dividing, all in scientific notation. And we've learned this, so this is just a review, and this is for you to write this in that student companion of yours. So here we go. For addition and subtraction, you must have the same exponents in order to do this operation. In order to add or subtract in scientific notation, you have to have the same exponents. Often, and we've seen this, we have to change one, which will also change, we'll have to change one of the exponents, which will also change the decimal place of the coefficient, which would be the number in front. So we've seen it where, let's say you have 6 times 10 to the 6th, but this 6 here needs to be a 4. So you move it down to 4, which then makes this, oops, which then makes this move up. Well, how do we move numbers up? We move the decimal point over to the right. So this now becomes 600 times 10 to the 4th. So you've seen that previously this week. Now let's move on to dividing. Dividing in scientific notation means the exponents are subtracted. And we've seen this already on last night's assignment. And in multiplying, the powers of 10 or exponents, oops, I meant to change that to exponents. Same thing. Exponents are added. And always we want to make sure down here, this note, all of our answers are in scientific notation, meaning our front number is less than 10 and less than 10 and greater than 1. All right, flip over. We are on our first got it, which puts us at page 88. It says simplify 5.9 plus 4.3 times 10 to the 5th minus 2.2 times 10 to the 5th. And we notice that we're adding or subtracting these, so we know all of our exponents have to be the exact same, and they are. Makes it easy on us. So first we're going to add 5.9 plus 4.3. And we get 12, carry the 1, 10.2. So then from that, we want to subtract 2.2. So we have 10.2, subtract 2.2. Remember, we're always lining up these two decimals when we are adding or subtracting decimals. So 2 minus 2 is 0. We have to borrow. 10 minus 2 is 8. Our answer is 8.0, or actually, since we're doing scientific notation, 8 times 10, and then our exponent stays the same, times 10 to the 5th. So down here it says, is it possible to add or subtract two numbers in scientific notation when they do not have the same power of 10? And explain. And yes, it is possible. Yes. All you have to do is change the power of 10, or the exponent, and the coefficient, which we had practice with on Monday. Coefficient. So we've done this before. Even though this example up here is pretty easy because all the powers of 10 or exponents are the same, it is possible to change them. Okay, so now you try. Why don't you go to page 90? Go to page 90 and try the first one. Same thing. Pause here and see if you get it right. All right, so we see that underlined in green, all of our exponents or powers of 10 are 12. So they're all the same. We can just go ahead and do it. 6.9 minus 2.6 is 4.3. 4.3 plus 3.4 is 7.7. So our final answer being 7.7 times 10 to the 12th. Okay, and we're at our second got it. This is on page 89. And now we are working in some word problems. So the key here is going to be which operation do they want us to use? We have to figure that out. So it says about 1.0 times 10 to the eighth bacteria live in a human body. So that's like a lot. That's like 1 with 8 zeros after it. If there are 2,000 spectators at a football game, how many bacteria are living in the spectators? So we're basically saying 2 times 10 to the what power? Third. That's how many people are at a football game. Now we're going to multiply that by how many bacteria are in each one of those bodies, which is 1 times 10 to the eighth. That is a lot of bacteria. Now notice our exponents. Our exponents are 3 and 8, but we're multiplying, so it doesn't matter. Now with multiplication, we multiply our two coefficients, so 2 times 1. And then we're going to add, so that's our first operation. Then we're going to add our exponent. So this is 10 to the third plus 8. So 2 times 1 is 2 times 10 to the 3 plus 8 gives me 11. So there's 2 times 10 to the 11th bacteria at that football game. Ugh. And in case you were wondering how big that number looks, that's 2 with 11 zeros coming after it. That's like 200 billion. Ugh, gross. Okay, now do you try. So please go to page 90 again. Go ahead and try number 2. Pause here, see if you get it right. All right, so this problem is kind of interesting. They want you to tell us how many dust mite droppings can be found in an average home each month. If you read it, you know that. So you're going to multiply 2.5 times 10 to the fifth and 1.5 times 10 to the fifth. You multiply 2.5 times 1.5 and get 3.75. And if you don't know how I got that, my work is over here. And then you add your exponents, and you should get 10 to the eighth. So that's how many dust mite droppings can be found in a home each month. Ugh. All right, now back to our got it. We're back on page 89. The biggest stars are known as red supergiants. One example of a Betelgeuse is about 300 miles wide. 1 AU is about 93 million miles. What is the width of the Betelgeuse AU? Or should I say Betelgeuse in AU? So AU just means astronomical units. So this is a unit that astronauts use basically to measure width of stars. So what they want us to do here is divide. So we're going to put both of these in scientific notation. So 9.3 times 10 to the 1, 2, 3, 4, 5, 6, 7th power. I'm going to divide that by, so that's 1 AU. That's 1 astronomical unit. We're going to divide that by how many million miles wide one star is. Well, that's going to be 3.0 times 10. And if we write 300 million, we're at 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the eighth. So what we want to do now is divide our two coefficients, our two front numbers, and then subtract our exponents. So 9.3 divided by 3.0 is going to give me 3.1 times 10 to the 7 minus 8. And what is 7 minus 8? It's going to be 3.1 times 10 to the negative 1. So the width of one star is only 3.1 times 10 to the negative 1. Remember, negative exponents means small numbers, AU, or astronomical units. So remember what that means. That means it's 0.031 AU of a unit. That's a small unit, but it's a big star. Okay, so now flip to page 90 again, and go ahead and do number 3. See if you can do it. Pause here, check back. Okay, so we just divide 4 times 10 to the 7th, which is the distance around the Earth, and then we divide that by the amount of ants can fit in a meter. And we want to get it to the nearest tenth. So after we get to the tenth, we can stop. It's 8.1 times 10 to the 7 minus -4, which actually gives us +4. So 8.1 times 10 to the 11th ants. Now that is a lot of ants. In case you were wondering, that is, let's see, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Woo, that is a lot of ants here. 810 billion ants to wrap around the entire Earth at the equator. Okay, so now go ahead and start the digits 4.4 homework. It is on your to-do list.